6.3b. So today we're going to learn integrals with antiderivatives. Integrals with antiderivatives. Aren't we all antiderivatives? Yes. Okay. So far, we know that the integral is the area under the curve. Okay, we know that. And we've been able to find the area a few different ways. So let's just recall that. Find the area. And we did it first. We did it using RAM. And RAM was nice. It was pretty good. But RAM is just an estimation or an approximation, if you knew what RAM stood for. It's just estimating what the area was. Okay, so it was okay. Then we did known formulas for area, known area formulas. And that's pretty good if you're pretty good at geometry. You know, there were areas of a triangle, trapezoid, circle. Okay, but what if there isn't, a specific area? Like if we were integrating underneath a parabola, that doesn't make a really nice square or rectangle or anything like that. So we also learned to do F and I and T on our calculator. And then today we're going to learn the fourth and final way to find the area, and that is to use the antiderivatives. I don't have a proof of why this works or how it works. I'm sorry. But here it is. If you want to find the area under the curve, or the integral from a to b of f of x dx, this is equal to, this is how they write it, capital F of x from a to b, okay, where f of x is,
in least sense, I promise it makes sense.
yeah. Oh, this is what you guys do in physics?
This morning I couldn't figure out how to do it.
If we would have had math in the morning, this would have worked.
Oh, yeah? F of x is the antiderivative. We'll talk about what that is again. And then this would then be equal to f of b minus f of a. Okay? So there it is. All right, so let's talk about this.
Why are they capital X?
They just labeled this as the antiderivative of lowercase f. Yeah. So for example, if let's just find, let's not do an integral yet, but let's go ahead and find, let's say that f of x equals x squared. Let's find the antiderivative. So in other words, if we were going to take the derivative of f, big capital F of x, we would get little f of x, okay? So yeah, so what would it be? X cubed over 3.
Oh, 3.
Mm-hmm. X cubed over 3 plus c. Okay, how do we get that? Okay, derivatives, you would take the number and multiply, subtract 1 off. We're doing the exact opposite. We're adding a number to our exponent, and then we're dividing by that number. So instead of multiplying and then subtracting, we're adding and then dividing. All right, so that's what it would be. Okay, so let's go ahead and do one now. Number 1. Let's find the integral from -3 to 1 of x squared dx. Okay? All right, so with definite integrals, you do not need the constant there because the constant's just going to subtract itself out. I'll show you what it looks like with it, okay? So we go ahead and we find the antiderivative of x squared, which we already did, and it was x cubed over 3 plus c. And I'm going to take this from -3 to 1. Okay? So now I'm going to take 1 and plug it in. So I would get 1 cubed over 3 plus c minus -3 cubed over 3 plus c. Okay? So you take capital F of 1 minus f of negative 3. And what happens, do you see what's going to happen with the c's? They're going to cancel out. So you don't need to put them there, ever. Okay, they're just going to always cancel out. All right, so then when you get 1 cubed over 3 is 1/3 minus, what is that, negative 9 over 3. Yeah, negative 3? No.
No.
9, 27. Yeah. So then you get 9 1/3. And that's what the answer is. And so what we just found is, if you were to, draw a picture of what just happened here, here's just your basic parabola. And we integrated from negative 3 to positive 1. We found the area under this curve. Pretty cool, huh? Pretty cool that you can find the area of that. Because it's not one of your shapes that you know. It was very powerful back in the day. Okay, let's do some more. So fun. Number 2. Number 2. So you can't use your calculator to do the F and I and T. I'm sorry. We're going to integrate from negative 1 to 1 for 2x to the 4th minus 4x squared plus 2, all that in parentheses, dx. All right, you ready? That's gross. Okay, so here we go. We have to first find the antiderivative. Don't worry about plus c. When we find the antiderivative of integrals that are not finite, we will have to write plus c every time. Right now, you don't need to worry about it, okay? All right, so let's find the antiderivative. So you're going to add 1 to 4, which is 5, and then divide by that number. So I would probably write that as 2/5 x to the 5th. Okay? Then add 1 to that 2 to make 3, and you get minus 4/3 x cubed. If you are ever unsure of what you're doing, you can actually take the derivative to see if it's matching up with here. That's what I sometimes do if I'm a little worried. And then 2 would be what? 2x. And then we would need the plus c, but we don't. And so we're going to evaluate this whole thing from negative 1 to 1. Now, would I make you do this by hand? No, I've learned my lesson. So you can use your calculator. So we can plug 1 in. And if you plug 1 in, you will get 2/5 minus 4/3 plus 2. So that would be capital F of 1 minus negative 1 goes in, and I get negative 2/5, bless you, plus 4/3 minus 2. And use your calculator if you want to. That's fine with me. You can put the whole thing in just like that. Let's see what you get. What'd you get? 32 over 15? You got 4? Let's see. 2/5.
No, I didn't get 4.
Oh, okay. Minus 4/3 plus 2 minus negative 2/5
You said just 4 over.
plus 4/3. Is it? Minus 2. I got 2.1333333. Yeah, 32 over 15. It came in as improper fraction. That's fine. That's beautiful. Look how pretty that is. Okay, let's do a harder one. Here we go. Number 3. This one always brings some problems, some trouble to your life. Here we go. We're going to integrate from 4 to 7 for 1 over x minus 3 dx. Oh. Okay. If you think about this one, you're supposed to think of how we're going to find the antiderivative here. This, if I were to rewrite this as x minus 3 to the negative 1, right? I would say, okay, I got to add 1 to this, and what happens is I get 0. So that's not it, okay? Does anyone have an idea of what it is? Do you know? No? Do you remember what you took? If you took the derivative of something, it gives you 1 over x. Do you remember what that was? Natural log. So this is natural log of 1 over x minus 3. That's the antiderivative. Hard, right? Terrible. I'm sorry, of x minus 3. Yeah, my bad. Ew, what did I just do? Cancel. Natural log of x minus 3. There we go. So if you took the derivative of that, you would get 1 over x minus 3. You see that? I know. It's hard. It's hard when it's those fractions and stuff. All right, so now we're going to evaluate this. 7 from 4 to 7. So we got to plug in natural log of 7 minus 3, which would give us the natural log of 4 minus the natural log of 1. The natural log of 1 is just 0. So this would be natural log of 4. And you can give me a decimal for that if you want to. Okay, two more. Number 4. I think the closer it gets to spring break, the more tired we all are and like ready for it.
Oh yeah, tell us about it. We all have an
Yeah,
essay.
I did?
No, not you.
Oh, everybody?
else.
Everybody's giving homework? A lot of homework?
Josh
Oh,
knows.
okay.
Well,
My
we
essay-
said this essay's the easiest one.
It's the hardest.
No, it's because the reason why it's so hard is because we don't have like exact rules of what they want from us.
Yeah.
What's it on?
Yes.
Frankenstein.
Oh, okay.
I don't like.
It's not the
No.
monster.
I want
That's not the monster.
Frankenstein is not the monster.
Oh, good. He scares me. Okay, so integral from -3 to 1. 3e to the x minus 1/2 dx. Trevor, e to the x. There it is
Oh,
again.
yeah, okay, it's not S.
No, sorry. I didn't post that video. Okay,
No, it's
no. Sorry about that. Let's go ahead. Let's take the antiderivative. The antiderivative of 3e to the x is what? 3e to the x. Yes, that's not hard at all.
correct.
See, and then like think about it in your head. Like if I took the derivative of 3e to the x, it would just be 3e to the x. And then the antiderivative of -1/2? Yeah, -1/2 x. And we're going to take this from -3 to 1. All right. Kind of almost the worst part is plugging things in, huh? I think. All right, so we're going to go.
Wrap it and then try to so you know.
Oh, there you go. That's true, huh? All right, so then you plug in 1 and you get 3e minus 1/2 minus 3e to the -3 minus 1/2 times -3. Okay, so you plug them all in, and you can use your calculator, of course. Go ahead and put that into your calculator. Ew, it has in terms of e on my paper, but I don't want that. Okay, so use parentheses, you know, they're there. Use them. 3e minus 1/2 minus 3e to the -3 plus 3/2. And I don't know if you got it, about 6.005. Yeah? So that's the area under that most disgusting graph that I don't even know what it looks like. Okay.
Plug in E without it.
It's over above the division symbol. It's just E.
Oh.
Yeah. Or you could just do to the first power if you want to just E. Okay, last one. Number 5. The tapestry is so good today. All right, here we go. We're going to integrate from 0 to pi over 4. Yeah, last one. 0 to pi over 4. There we go. Of 2 cosine 2x dx. All right, this is the trickiest one of all. Hi guys, how you doing back there? Pretty good? Okay. All right, this is the tricky. I forgot they were even here. All right, haven't seen their papers come through in a while. So, all right, 2 cosine 2x dx. Now, you want to try it? Yeah, you try it. You think about it. So you could go 0 to pi over 4 cosine of 2x dx. All right, so I know that the antiderivative of cosine is sine, right? So it would be sine of 2x, but if I was going to chain rule that, I'd have to divide by 2 instead of multiply by 2. Right? But then there's this 2 out here. So they reduce. So I don't know if you did it that way.
Wait, why do we divide by 2? Oh, because you have to multiply 2.
So if I was going to take the derivative of sine 2x, I would get cosine 2x times 2. So, yeah. Actually, if you did it that way, and you didn't even worry about the 2, it would have made it equal it anyway. So, okay. So you get sine of 2x, and this is from 0 to pi over 4. So we get sine of 2 times pi over 4. Is that too many? Yeah. Minus the sine of 2 times 0. 2 times 0. So this is the sine of pi over 2 minus the sine of 0. And what is the sine of pi over 2? Do you remember?
No. No.
So pi over 2 is right here. It's 1.
Okay, I don't do it like that.
You don't do it like that? I know, nobody
There's
does.
a unit circle.
Sine of 0, 0. So the answer is 1. Either way. You do it wrong, you get it right. That's fun. There you go. Oh, unit circle. So this is the point 1, 0. So sine of 0 is 0. This is the point 0, 1. So the sine of pi over 2 is 1. The antiderivative is actually sine 2x. So if you have over here 2 cosine of 2x, right? And I'm trying to find the antiderivative. So if I do sine of 2x and I take the derivative of this, I would get cosine of 2x over 2, or times 2, if I was going to take the derivative. So the 2's right there already for you. So then it's just sine of 2x. So if I take the derivative of the sine of 2x, sorry, I didn't mean to write that. It would be 2 cosine 2x.
We have a physics quiz. What is it? You never
Right?
told us what it is.
So here, do this. If I say y equals sine of 2x, what would y prime be? Take the derivative of sine, which is cosine,
What color are you in?
and then the derivative of the inside, which is 2. So that's what that is. So then it has to be sine of 2x. I know those are really hard. We're going